Good morning, mathematicians. Today we are going to be reviewing Pythagorean theorem. Now this should sound really familiar from geometry class, so we're just going to do this as a quick refresher. So first things first, there we go. Pythagorean theorem is a statement about the sides of a right triangle. Now remember, in a right triangle, one angle is always equal to 90 degrees, and that's usually indicated by like this little box right here. It has two legs, which are the closest to the right angle. So in that case, that would be these right there. And it has a hypotenuse, and the hypotenuse is always its longest side, and it's opposite the right angle. So this one right over here would be the hypotenuse. And we can see right here, opposite the right angle, and it is the longest side. Okay, so when it comes to doing Pythagorean theorem, the most important thing is that we want to make sure that we are labeling the sides as they should be. Now, A and B are always going to be the legs of a right triangle, and the hypotenuse is always going to be labeled as letter C. So we end up with this formula. A squared plus B squared is equal to C squared. And whenever we are looking at this formula, we're using it so that we can find a side. Interesting. Okay. There you go. All right. We're using this formula so that we can find a missing side. So we can see right here that we have this one, A, matching up with its leg over here. We have this B matching up with its leg over here. And the hypotenuse C matching up with the hypotenuse over here. Now, it doesn't matter which legs are labeled A and B. You can swap those, but the hypotenuse is always going to be labeled C. All right. So why does this work? Well, Pythagorean theorem comes from the fact that if we take a right triangle and if we took the lengths of them, like in this example over here, and if we created a box or a square off of that side, the number, the area that this box would contain plus the area that this box would contain would be equal to the area of the hypotenuse. So if we add the two legs and made a box area out of them, and added it up, it would equal the box area of the hypotenuse. So that's where the theorem itself comes from. So let's see what this looks like in practice. So we have an example triangle right here labeled JKL. So I'm going to say triangle JKL. And we can see that we have side lengths JK and side lengths KL. So we have side JK and we have side JL. Now I'm writing these out so that you can be reminded of what all of the symbols mean in mathematics. Remember, triangle means triangle. Two letters with the line on top of it indicate a side. And it looks like we are trying to find side JL. So how would we do this using Pythagorean theorem? Let's go ahead and erase what we have so far. Okay. So how are we going to use Pythagorean theorem to solve this? Well, we have our formula, a squared plus b squared is equal to c squared. So first thing I'm going to do is I'm going to label my triangle. I'm going to label the legs first. So I know that the legs are closest to the right angle. And then my hypotenuse, or the longest side, the side that is opposite the right angle, is C. All right, so now that I have all of that labeled, I am just going to take what I have and plug it into my formula. So instead of A, I'm going to swap that out for 17 squared plus, and then instead of B, I'm going to swap that out for 13 at the squared. And that is equal to, we don't know C squared, so you can leave it as C, or if you want to change it to X so that you're solving for X, that's perfectly fine either way. Now what I'm going to do here is I'm going to simplify this part in my calculator because that's just an expression I can solve out. So 17 squared plus 13 squared, according to my calculator, simplifies to 558. And again, bringing down what I have left on the other side. All right, so now if I'm trying to get C by itself, what I want to do is get rid of this squared right here. So the opposite of squaring is square rooting. So once I square root that side, the only thing I'm going to be left with is C. That's how I can undo it. And then remember, in algebra, anything I do to one side, I need to do to the other side. So I'm going to have to take the square root of 458. and I end up with 21.4. So it looks like that is the length of this missing side, 21.4. Okay, just to recap, label my sides, plug into the formula, simplify, and solve for C. Okay, so looking at this problem, I already wrote out our formula. A squared plus B squared is equal to C squared. First thing I'm going to do again is label my triangle. I can see my hypotenuse is right here across from the right angle. And then I'm just going to label the legs A and B. Doesn't matter which way they're labeled. Now I'm going to go substitute. A becomes 6. I'm waiting for it to catch up. A becomes 6. Wow, the Wi-Fi is being horrible. All right, let's see if my hotspot will be any better. Okay. That's annoying. All right, so I'm going to go ahead and plug in 6 for A. Add on my squared. Plus, and now I'm going to plug in B. Oh, I don't have B, so I'm just going to leave it as B, but you could substitute an X if you prefer. And it looks like C is 9. All right. Now I'm going to simplify where I can. I know that 6 squared is 36. Plus, I can't simplify B squared, so it just stays B squared is equal to 9 squared, and 9 squared is 31. All right, now I'm going to isolate B because that is what I'm trying to solve for. B, I'm asking myself 36 plus what number squared equals 81. So I'm going to have to do some inverse operations. That cancels out. I'm just left with B squared is equal to 81 minus 36, which is 45. Now we're kind of are at the same place where our last problem left off at. I have B squared, and the opposite of squaring B is to square root it. So once I do that, the only thing I'll have left is B. Don't forget to square root the other side. And the square root of 45, it looks like, is 6.71. All right, so that is our missing side, 6.71. Okay. Sorry there were so many technical difficulties while I was making this video, but I hope that you were able to review Pythagorean theorem. You are ready to move on to our mastery check-in exit ticket that is on Google Classroom. All right, y'all. Good luck.